Bismillahirrahmanirrahim. This is a bridge rectifier circuit. It has 4 diodes, a transformer and voltage source V1 with 20 volts peak and 50 Hz frequency. The next component is the transformer. You can adjust turn ratio from this panel. Primary turns are 4 and secondary turns are 1. The transformer is connected to this bridge connected diodes like this, and these 4 diodes are connected to load resistor R1 of 1 kilo ohm. Diode D1, D2, D3 and D4 are connected back to back. This probe will show the rectified image appeared at D2. The another probe, it will show rectified waveform at D4. Now let's simulate the circuit. You can view 3 waveforms. This is voltage appeared at D2. This is voltage appeared at D3, D4. Both have the same peaks, that is 4.3 volts. Actually, at secondary winding we get 5 volts, and here we get a peak of 4.3 volts because of the diode drop. The light blue waveform is the output waveform V out, and it has 3.6 volts peak. It includes 2 diode drops because each waveform is going through two diodes. So plus 0.7 and plus 0.7, 2 drops included. Now come to the next part. This is transformer turns ratio. 4 primary turns, primary voltage is 20 volts peak, secondary voltage is going to 5 volts. The direction of current will be like this during positive half. The positive peak appear. This is the positive peak, and it will go from diode D2 to load resistor, then it will flow from diode D3 and ended up here. This is when the positive peak appear. Now what happens when the negative peak appear? Polarity reverses. You can see there is a negative polarity at D2. So this is the anode of D2, and it has negative polarity. So it is non-conducting in this cycle. Similarly, there is a positive polarity at the cathode of D3, and it will remain non-conducting in this cycle. This is the negative peak. What is the current part during this cycle? You can see the positive voltage appear at D4, and it makes it conducting. As you know, the current will always flow from higher potential to the lower potential. So in this case, the current will flow from positive terminal to negative terminal. The current will flow from like this in this case. and ended up here. I hope you understand the direction of currents in each half cycle. Now, this is the output voltage, which is equal to 3.6 volt peak. This is 3.6 volts, and this is DC and it is pulsating, but we need to have a capacitive filter here. Another thing to remember is the current will always flow in the same direction through the load, that is from top to bottom. That's why both peaks appear in the same direction. Similarly, during a negative half cycle, the current will still flow from top to down. Now add a capacitive filter. Here the capacitive filter with a value of 470 microfarad is added. Let's simulate the circuit. We get a smooth output. The ripples are still here, but these are acceptable. This is the charging time of the capacitor. After it gets charged, we get a smooth DC voltage ahead. Now, what is the average DC value of the pulses we get? With the help of this formula, we can get the average value of the pulses or the area under the as you know, the pulses appear almost after pi, so the time period is pi. Integrate over 0 to pi, that is, these are the pulses, and each pulse appear at after pi. This is the formula for area under the curve, and with the help of this formula we can get average DC value of these pulses.